Thank you. Okay, so after lunch, the time is full, we're a little bit sleepy, so don't worry too much about it. This is an introduction to Akka, so it's not going to be too much of a content, but what I'm hoping is that if you've never heard of Akka, at the end of this talk, you should be able to walk out of that door and say, hey, if I want, I can write something in Akka. So that's my goal for today. Thank you, Marco, for the introduction. I'm Daniela, and what I love to do is to play with things and write about it. I have a blog. Please visit so I can break my personal record of visits. And I'm the tech lead at OVO Energy. We use a lot of Scala, Akka, and that's where I build most of my experience. Don't get me wrong, I'm not an expert. I'm just someone that is learning. So, what we are going to do today, we are going to remind ourselves why concurrency is important, and we will compare what we did in the past and what's the current trend. Then we are going to explain a little bit what's the Akka philosophy, and then we will describe a little bit how actors work. Finally, enough with talking, we will move and do some extra code that will put everything together. So, I'm not going to spend too much time about this. The idea is that now concurrency, being able to solve concurrency in an efficient way is more important than ever. You know, hardware is really cheap, and having cheap hardware has encouraged the development of multi-core CPUs, distributed systems. We have a huge amount of data that we can use in our systems. So it's really important that we know how to process quickly, how to parallelize it, how to share the information. And this is basically what concurrency is all about. So, what the community did in the past, it was using a thread lock monitor approach. I don't know about you, but for me, it was always like, oh my God, it's too scary. I never managed to digest the topic, never. It was probably because I couldn't find anything in the real world that could fully translate it. It was really difficult for me to design and maintain my code, and because it was unpredictable, I was never fully sure that it was working. Also, when I had a bug, I don't know how many of you had bugs in production because of threads behaving in a weird way, it was impossible to test. So probably because now concurrency is more important than ever, the community has revisited some different approaches. So can we do better than a thread lock monitor approach? We could do better. Another solution to this classic approach is the message passing one, where think about it like people that are sending emails to each other. These messages, emails, wrap all the shared information, and these messages are used to communicate between processes, people. So that seems to be quite simple. I can easily translate it to something that is human. So, good. But until now, there wasn't a framework that was really easy to use. So people were a little bit scared of how to apply this approach, and they were probably relying on the previous approach, I call it the hold approach, although it's not hold, it's just different. So, what is Akka then? Akka is a framework that implements the message passing approach. So this is taken from their website, and they say that if you use Akka, you can build powerful, concurrent, and distributed application more easily. Okay, fair enough. What they say is that, that Akka has 5 properties. The first one is that it's simple, concurrency, and distribution. Fair enough, it's message passing system. So if it doesn't handle concurrency, there is a problem there. So good, easy. Resilient by design. What that means? What actually means is that if you have a failure, if your system is sick, your system will be able to recover by itself. That's pretty cool. High performance. As I mentioned before, we have billions of data that we need to process. High performance means that we never block, so everything is asynchronous. So that's, again, something really cool. Elastic and decentralized. This basically means that the code that you have, it will work on one machine, on 20 machines. So you can spread your system from one machine to a lot of machines just by changing the configurations. How cool is that? It's like amazing. Extensible. Extensible just means that if you suddenly need more resources, it's really easy to allocate more actors. I'll explain what actor is in a second. That will help you process more. So that sounds quite promising. But the key is more easily. Is it going to be really easy? I hope that at the end of this talk you're going to say, yeah, it's pretty easy. It supports not just Scala, it supports Java, and I think from April they announced that they will support .NET as well. Not that we want to write any code in .NET, but that's another story. So one of the tools that Akka provides is Actor. Another tool that Akka launched yesterday is Reactive Stream, next room. So let's see a little bit what Akka is. Okay, so I'm a really practical person, so I'm going to give you my definition of Actor. Actor for me is a monkey sending emails. Okay, I'm not crazy. I can explain why is that. It's a monkey because he's lightweight concurrent entity, so it's not really smart, but it's able to process things. It's event-driven, so it's waiting for something to happen. It's not smart enough to know by itself what it has to do, but it's waiting for something to come. In fact, what happens in the actual implementation is that an actor is just a class that has a loop that is waiting to receive events. So that's more or less makes sense. And also an actor has a mailbox where he receives all these messages, and all these messages are processed asynchronously. The other reason why I said that for me an actor is a monkey is because monkeys never stop. They're always moving. They're always trying to do something. That's exactly what an actor should do. We should never block an actor. It should keep processing and receiving messages. And also, the other feature that actors have is that they can have mutability. So they have a status. Let's see what kind of life our monkey has. So this is a picture that has been taken from the Akka in Action book. If you really want to know more about Akka, it's a book that I strongly recommend. So nothing special here. An actor can be started, restarted, and stopped. And in the moment we restart an actor, what actually happens is that the current instance is destroyed and the new one is created. In particular, what Actor does is that it gives us the opportunity to customize within a certain limit this life cycle. So we have access to a few functions: pre-start, pre-restart, post-restart, post-stop, that will allow us to add something to this procedure. So for example, something that we're actually going to do is, after my actor is being created, get some resources, print a message, send a notification to someone. We will be able to do that by using those functions. Okay, so we have seen a little bit what is an actor and how his life is structured, but okay, it's cool, but how do we put all of this together? Because right now, okay, cool, you can send messages, but is there a well-defined structure? The answer is yes. So this is a picture taken from the Akka website. The idea is that Akka allocates two resources that are completely separate. When we create a system, we will have a system guardian that is reserved for system stuff. We will probably never use it, unless we do some cool stuff over there. And when we usually play with our actors, what we do is that we create our actors below the user guardian. So as you can probably imagine, what happens is that all the actors are structured as a tree. So in this way, we are able to identify each actor by the path, or if you want, the URL. And that also is why we can easily move the code from one machine to multiple machines without doing nothing. Because all the actors are not actually called directly, are called using the path, using the reference. Obviously, there are some rules. Otherwise, it wouldn't be a well-defined structure that it's easy to supervise. So the first rule is that your parent node is your supervisor. So everyone has a supervisor, but the first node that we have access to, that is, again, the /user guardian actor. Obviously, what I wrote there is your children follow your destiny. It's a little bit weird. What does that really mean? It simply means that if your actor get restarted, stopped, or started, so will be its children. So in this way, we make sure that the system is consistent and we don't have any zombie going around all over the place, and that wouldn't be nice. But the reason why this structure is really important is because it allows us to handle exceptions really, well, not really easily, but in a way that it's easier than before. The idea is that, I'm an actor. I have a problem that I don't know how to resolve. Probably I crash, there is an exception. What I do is that I delegate my emergency to my supervisor. If your supervisor will basically do exactly the same until we will reach the guardian, the user guardian, so /user. If even the guardian actor doesn't know how to handle this exception, what has happened is that the system will shut down. So I personally really like the supervision approach that Akka has. And the reason why I like it a lot and it's really powerful is that what you usually do is that you embed in your code somehow the exceptions. While in this way, we are going to see that it's completely separate from the normal execution flow. And that makes it really easy to handle and making sure that you are not forgetting any case scenario. Okay, cool. So enough with the talking. Let's do something practical. So what we are going to do now is we have four core operations on actors. So we can create an actor, we can send messages to an actor, we can become, and we can supervise an actor. So, demo time. My last tweet has this link, so feel free to open it if you want. My tweet account is @Daniela Sfregola. Okay, so are we ready to do some coding? Yes, we are. Okay. Okay, I was supposed to write this live, but I got scared. So let's pretend that I'm typing this line by line, so please don't cheat and read it all. Okay, let's start with the first line. First of all, how many people are familiar with Scala? Good, really good. How many people are familiar with the Scala console? Okay, so the idea is that what I'm actually writing, let me show it to you. Big enough? Hello? Good. Okay. So the code that I'm writing is just a script. That means that we can easily run it into a Scala console, Scala. So I'm not sure how many beginners we have in the room, but basically, in my opinion, this is the best way to learn Scala. The reason why I say that, because if you're not sure how something behaves, you can just write it here and see how it goes. So for example, val A equal something. It will tell you exactly what's its type, what's its value. We can do exactly the same thing with scripts. We can load them and see the result. Okay, cool. Okay, let's go back to our demo. So the first part of our demo aims to show us how we can create and send messages to an actor. Okay, question over there? No? Okay, cool. So first line, import Akka actor. That's fair enough. We have to use the Akka actor library. The second part that we need to do is defining our actor, or actually, sorry about that, I completely forgot. What are we doing here? Okay, sorry guys about that, I completely forgot. So our goal for this part of the demo is to write a really simple script that will basically create an actor system, create an actor in it, and this actor is not going to do anything special. Every time he receives a message, it's going to print it out. So baby steps. The first thing that we do is define the behavior of our actor. So all we have to do is to create a class that extends the actor trait and define the receive function. And the receive function in this case, all it does is, no matter what you receive, you just print it out with your path, just to confirm that what I said is true. I didn't lie. Never trust people. And the message. Okay, cool. So we got so far 9 lines of code. Good. So let's play a little bit with our script. So how do you create the system? Actor system intro Akka demo. Easy enough. So this command is going to basically create. It's going to basically create that. So we will have here at the top intro Akka demo. Whoops. And then we will have this small tree that initially is empty because we didn't attach any actor. Then with we are going to create an instance of our simple actor, and we are going to call it simple. So with that line, what is going to happen is that because we did system dot, we are attaching the actor to our /user actor. And then, just with the exclamation mark, we can just send whatever we want. So we can send a string, we can send a list, apples, whatever you want. Okay, so as I said before, never trust people. So let's try it out. Okay, load demo part1.scala. So this is exactly the file that I showed to you. We load it. Cool. So we can see that we have created an actor system called intro Akka demo. And we have created an actor that has been given the path /user/simple. And then we printed out 2 things. Yo, this is a message, and the list of 1 to 3. And hopefully, that was exactly what we wanted to do. Cool. So, simple actor, yo, this is a message, and the list. Are there any questions so far? All clear? All clear? Good?
What is props?
Props is just the way Akka creates an actor. It just makes sure that your actor, basically it returns a reference rather than the object itself.
It's like a new in Java, creating instance of...
Similar, but not exactly the same. The idea is that what you normally do is that you create the object and then you get back the object. Here instead, because they need to protect the actor, because as I mentioned before, you can scale as much as you want by changing configurations, they actually give you an object that contains the reference of the actor. That's just to stop you from accessing the actor directly. That's all that thing does.
I'm creating an actor.
Yes.
Just creating an actor.
Yes. Basically, yeah.
When you create the system, you also create the root guardian and the other guardians, or just, you know, the top level, I'm someone that know the bubble space element?
That's done automatically by Akka. So I don't care about it.
Great.
It's done automatically. Cool. Any other questions?
Yes, sorry. Is this mechanism similar to the message-driven bin of AGB infrastructure? Message-driven bin? Receiver and sender, like...
Yes and no. In the sense that in Akka, you see that exclamation mark?
Yeah.
That's a fire and forget.
Okay.
So you send the message and you don't care about it.
I send the message to who any actor can handle it.
Any actor?
No,
No.
you are sending the
Just
message
to
to a
one
specific actor.
Okay.
So obviously that specific actor will know how to process this. Anything else? Cool, let's move to part 2. Yay. Cool, so I've seen how we can create and how we can send messages to actors. What we are going to do now is we are going to play a little bit with the status of an actor. So we are going to play with become. So our goal for the second part is to create a simple script. It's basically going to be almost the same as this one, where we want an actor that will print a message the first time in English, the second time in Italian, and so on and so forth. Okay, how do we do that? Cool. Similar as before, we import the Akka actor library, and this time we defined the message that our actor will process. So our actor will wait and process for messages that are person. And our actor, again, hello actor, will implement a function receive in English that is exactly the same as before, but we have added a little key here. So note the import context here and the become, and similarly in Italian as well. The idea is that when I run the become, my receive function is going to change. So after I run this piece of code, my receive function is actually going to be this one. And when I run this piece of code, after I run this piece of code, my receive function is going to be this one. So this way, you can basically really easily change the status of your actor. Let's see if this works. Yes, we have plenty of time. Okay, really similar as before. Sorry, question? No? Okay, cool. Similar as before, we create the system, we create the actor, and then here, what we do is first send something that is not a person, case class person, but it's a simple string, and this should be ignored. And then we send a few person entities, and we should notice that the actor is processing them differently. So as before, let's try it out. Okay, cool. Load demo part2.scala. Wow, it worked. So, as usual, we have created the system, we have created the actor, note the path, and let's see the behavior. So, hello Martin, English the first time, ciao Scala Italy the second time, and so on and so forth. So, let's look again at our code. This should be ignored. It was ignored, so it's good. Person Martin, we used English. Person Scala Italy, we use Italian, and so on and so forth. Become is powerful, but we need to be careful not to overuse it. In my experience, some people sometimes misuse it. Remember that you do have a better tool if you have a lot of different statuses. For example, you have a state machine. So my suggestion for this one is use it if you have statuses that are easily linked together. If you have a more complex system, use a state machine. Akka does offer a doc tool for state machines, so it's cool, but be careful. Any questions so far? Nope? Good. Let's complicate things a little bit, and in my opinion, let's move to the most interesting part of this tutorial. So we've seen how we create actors, how we send messages to actors, how we can change the status of an actor dynamically. What about supervision? We said that we have a nice system to recover and heal the system by itself. Cool, let's do that. Okay. As usual, sorry, forgot again to mention what's our goal. So we have just done this exercise where basically our actor is speaking first in English, then in Italian. What we want to do now is introduce something that is going to make it crash, just because I want to show you guys what happens. And then we are going to have a supervisor that is going to recover us from the crash. So basically, when we are going to send something that is not a person case class, we are going to crash, and our supervisor is going to say, okay, boom, restart. So that's our goal. Let's see how we can do that. Again, this is always the same script. We are just adding and changing things. So as before, we import the Akka actor package. And what we do now is that we import the supervisor strategy. What is that? So in Akka, you have two standard options, and you can implement your own. But the idea is that either you apply your destiny to all your children, so all the actors that you are supervising, or you apply whatever you want to apply to just the actor that crashed. Okay, so that explains a little bit what is that. Again, our case class person, nothing new. So for the sake of this, for this demo, I've decided to add some messages just to make explicit that we are actually doing something with this actor, and I'm not lying. So what I've done is that I've used that life cycle that we've seen before. That is, just to remind you guys, this one. So we're going to use those functions down there to add some messages, so that it's going to be super clear that something is actually happening. Cool. So I'm not going to spend too much time on this. So we are going to print a message, yo, I'm restarting, when right after the restart has begun. And then we are going to print a message, restart completed, after the restart has been completed. Make sense? Good. Do you guys know, who doesn't know what a partial function is? Okay, cool, not a problem, we are here to learn. So, you know, do you have a play Lego, right? You have pieces and you can put them together. That's exactly what a partial function is. You have a lot of Lego bits and you put them together. So what I've done here is that instead of having this here and this here, code duplication, we don't like that. What I've done is that I said, forget about this, and put it in a function that it's a partial function. And then we play Lego. So what we do, we use or else that will put them together. So it is exactly the same as copying and pasting the definition of the partial function inside the in English and in Italian function. It's exactly the same. It's just more elegant and more functional. So it's cool. So when we start, the first time we receive will be a combination or in English or else crush if unknown. After we execute in English, we are going to become in Italian or else unknown, and so on and so forth. Okay, now the interesting bit, there is exactly 3 lines. How cool is that? Okay, so we have created our actor, and we know now that as soon as we send something that is not a case class person, it's going to crash. We are going to raise, we are going to throw a runtime exception thing, boom. Let's see what the supervisor does. So the supervisor is still an actor, and it will still receive messages. The only difference now is that it doesn't matter what he receives, he will forward it to the actor that he supervised. And we have done that by using the forward function and by creating our dear hello actor from the supervisor. So what we have now, we have /user supervisor hello actor. Make sense? Cool. And this is the magic. So what we are saying there is that we selected the one-for-one strategy, so we will, in this case, we wouldn't really matter because we just have one actor, but in this case, we will restart, or we will do, sorry, spoiler there, we will do whatever we want to do, just with the actor that crashed, not everyone. And this is a simple case, no matter what, as long as it's a runtime exception, then we will send the command restart to our actor. Cool. Let's play with it a little bit and let's see what's going on. Again, nothing new, same as before. We create the system, we create our supervisor. Sorry guys, should have done that before. We create our supervisor, and then we start sending messages to it. Note that because of this line, we will create the hello actor as soon as we create the supervisor. So we know that in the moment we call the supervisor, the hello actor has already been created. And then we just play with it. We send a few messages, and then we crash the actor. And then after we crash the actor, hopefully we will see that something happens and we are still able to function as nothing happened. Cool, let's try it out. Okay. Reset, forget everything. Scala. So what it should happen, if we remember exactly what we are doing, hello supervisor, we send a message, hello Martin, we should see hello Martin. The second time we should see ciao Scala Italy. The third time, hello Daniela, and then we should crash. In the moment we crash, the hello actor should be restarted, and we should start again from English, because English was the starting point, yeah? Let's see if it's true or not. Oops. Cool, let's analyze all of this stuff. Okay, we imported a few packages, we have created a class person and define the system, define the supervisor, note the path, and then we start sending messages. So the first time, hello Martin, second time to Scala, third time, hello Italy, hello Daniela, and then we send a string that crashes the actor. And what actually happens, yo, I'm restarting, restarted, completed. So our system was able to survive. We still have the stack trace of the error, so we still have tracked that something happened, and that's good, because if a crash happened, we need to know why. So that's really good. But our system was able to survive and to recover fully. Note that next time that we send a message, we go back to English. So that's pretty good in my opinion, because all of that is done in 3 lines. Are there any questions so far? Yes.
You said that the messages are processed asynchronously.
Yes.
So what if you can scroll at the if you can scroll at the bottom of the listing, the actor crashes when it receives this actor should crash the actor, and then you send another message.
Yes.
What happens, or it is possible that you send the message before the actor has restarted?
It is possible, and what happens is that that message cannot be processed because there is no final actor, and in that case it will put in a special place that is called that letter channel in Akka, and we will be able to access it and reprocess it if we want. But yeah, you're right. While we're restarting the actor, if the actor is there, we cannot process it. So this is not ideal, but it's better than completely having the system crashing.
Okay, thank you.
Cool. Any more questions? Yes.
So you said that, and I agree that thread and lock concurrency is basically a testing nightmare. But how do you test this stuff? I mean, mainly how do you test the interaction between actors? Because I believe you can have a deadlock even between 2 actors waiting each other to send a message, for instance.
So there is a test kit tool that allows you to test actors. What it basically does is that you can either choose to move from multi-thread to single thread, but be careful because you said something that you cannot have a deadlock between actors, simply because actors don't wait. So an actor will never stop and wait for another actor.
Okay, it is a semantic deadlock anyway. That the program is blocked because an actor is waiting for some message to proceed, to do something.
That's the point. You don't wait. You never stop, you never block. So all you do is that you process your message and then you do something else.
Okay.
So there could be a deadlock in the sense that you suddenly don't receive any messages anymore and no one is receiving messages.
In the sense that you are, for example, waiting for a message to move to a different state
Okay.
And that message never arrives. So you don't never move to a different state, and you never do the following action in your state machine. And there could be another action on the other side waiting for something else, and they are waiting for each other. This could be quite common.
The idea is that actors are completely independent from each other. So if your design has some interdependency, it is absolutely possible, but ideally you should try to avoid that. Obviously, bad design is everywhere, so that's something that we can do. I'm going to quickly wrap up. So hopefully now you have a little bit more, you have an idea of how more or less this works. As you mentioned with your question, Akka is a really powerful tool, but if you don't do things right, you can be in trouble, and you can quickly go back to the old life where you have threads that don't behave. There are some golden rules that are basically never block, going back to my monkeys. A monkey never stays still, never, it's impossible. Communicate only via messages. A monkey doesn't talk to another monkey. The problem with that is that in the moment you find other ways of communication between each other, you could basically introduce some shared data, and it's some shared data that doesn't have any protection. So you should try and keep all the shared data wrapped up into the message, or since we are here, Scala Italy, let's call it with the name case class or case object. Messages should be immutable. Again, that's why with Scala it's really important to use case classes. Think about writing an email, reading an email, and when you are reading it, someone is changing it. It's like, it would drive me crazy, to be honest with you. Messages should be complete and self-contained. So how many times you receive an email that doesn't have enough information and you have to send another email saying, sorry, can you provide more information? So it could seem not very important, but it's better to have a case class that it's a little bit bigger but contains all the information for an actor by itself to process whatever he's processing, rather than have interdependencies between actors, simply because communication does cost. So I don't know about you, but when I receive an email, I like to have all the information that I have in order to satisfy whatever they're asking for. Thank you very much for your attention. If you have any more questions. If you have any more questions, do we have time, or any more questions? No? Oh.
Is there a way to enforce type checking in message at compile time?
I have no idea. I'll be honest with you. I don't know. Sorry.
So there is a typed version of Akka. It's experimental, but there is a typed version of Akka. So you can try that.
Okay, thank you, Michael.
Okay, thank you very much. Daniela.